Hi, this is the last part now for the June 2018 Maths Higher Paper 1. This is question 18. It's a trig graph, not usually on paper 1, but they've given us a little bit of extra help on this one, so we can still do it even without a calculator. So we've got our graph of cos x, and we're asked to solve for cos x equals minus 0.9336. So that is right down the bottom. I always suggest you draw a line on because it helps to visualize the problem a little bit better. So minus 0.9336. Okay, and we've got two solutions. We can see those. So mark those one between 90 and 180, and another between 180 and 270. And we've got, to help us, we're told here that cos 21 is positive 0.9336. So I'm going to draw that one as well. So that'll be right at the top up there, look. Which means that line that comes down, that must be 21 degrees there. Okay, and 0.9336. Okay, and because of the symmetry of the graph, and you're always looking for symmetry in these questions, I can see that this sort of triangle-y looking shape, it's not really a triangle because one of the sides is curved, but that there is an exact replica of this shape here. Okay, it's upside down, but that doesn't matter. It's still the same width. So that's the same as that one, and it's also the same as this one. And that's how we're going to get the two solutions for our blue line, the minus 0.9336. Okay, so now we're looking for the width of these triangles. So from 21 to 90, that's a gap of 69 degrees, which means these other two must be 69 degrees as well. This one is 69 degrees more than 90, and this one is 69 degrees less than 270. And so to work out our answers, we do 90 plus 69 degrees is 159 degrees, so that's our first solution. And then 270, take away 69 degrees, is 201 degrees. That's the second solution. Okay, and that's the end of that question. So not too bad, as long as you sort of spotted the help they'd given us, the red line. Okay, part B of this last question is asking us to make a transformation of the cos x curve. So if we quickly go over, if you have y equals f of x, and f of x just happens to be cos x this time around, and then you put a multiplier in front, so 2f of x, what does that do to the curve? Well, it sort of stretches it in the y direction. I guess if this were science, you'd say that it sort of increases the amplitude of the wave. Okay, so we need to make our graph twice as tall and twice as deep as what a cos x curve would normally be. Now, a cos x curve normally starts from 1, goes down to -1 and back up. So this would be a normal cos x curve, something like this. It goes through 0, it's minimum -1 at 180, comes back up. We've just seen this on the previous page, so even if you couldn't remember, you could copy. Right, now we need to double the amplitude to do 2 cos of x. So it's going to start from 2 rather than 1, and it's going to go down to -2 rather than -1. But double 0 stays as 0, so they are fixed. So what we end up with is a graph that's just twice as tall with the same 0 values. Quite tricky to draw this with the tablet. Something like that. Okay, as long as you clearly indicated that it's twice as tall on your axes and you've got the right shape with the right zeros, you'll get the marks. Okay, and then last question, another transformation. So if we had y equals f of x, and then we did -1 outside of the bracket, what would that do? It would take the graph down 1. Okay, so again, if I draw in our normal cos graph, this shape, okay, down through 90 is 0, down to -1 at 180, back up through 270, and maxing out again at 360. Now every point moves down 1. So where we were on 1, we're now on 0. Where we were on 0, we're now on -1. where we were on -1, we're now on -2. So let's mark that. When we were on 0, we're now on -1. And when we went back up to 1, now that's only 0. So it's the same shape graph, moved down 1. Okay, well, I've missed my point there. Something a bit like that. Not the tidiest graph I've ever drawn, but it's moved down 1 because of the -1 at the end. And that's the end of the paper, so hopefully that's been useful.